Assalamu alaikum. This is chemistry 12th, and our today's lecture is about nucleophilic addition reactions of these carbonyl compounds followed by loss of water or elimination of water molecule. As in our previous lecture, we discussed the nucleophilic addition reactions of these carbonyl compounds, but in our today's lecture, as we are going to discuss these nucleophilic addition reactions followed by this elimination of water molecule. Now, as far as these reactions are concerned, both these aldehydes and ketones, they react with a number of these ammonia derivatives in a weakly in this acidic medium to form compounds containing this carbon nitrogen double bonds, and there is also elimination of water molecule. Now these ammonia derivatives, we have got various ammonia derivatives. We have got this hydroxyl amine, we have got this then we have got hydrazine, then we have phenyl hydrazine, we have got this semicarbazide. So these are the various ammonia derivatives which are involved in this nucleophilic addition reactions, where we see there is elimination of water molecules, water molecule with the formation of a double bond between the nitrogen and the carbon atom, or the carbonyl group. Now before going through these reactions, I would like to tell you how the reaction proceeds. Now as I have told you that these ammonium derivatives, they contain a lone pair of electrons. We see in case of this nitrogen, and we see lone pair of electrons in nitrogen. Therefore the reaction of these aldehydes and ketones, they involve the nucleophilic attack by the basic nitrogen compound on the carbonyl group. Since and these are the ammonia derivatives, so we see there is a lone pair of electrons on this nitrogen atom. Now these ammonia derivatives, they are weak nucleophiles, and the reaction is therefore carried out, or it is catalyzed by a weakly acidic medium. Since this being a weak nucleophile. Now in acidic medium, we see the this carbonyl oxygen, it gets protonated, and due to the presence of positive charge on this carbon atom, the protonated carbonyl group then it undergoes this nucleophilic attack by these ammonia derivatives. You can see this is an aldehyde, so this oxygen atom, it gets protonated, from this is H plus, it takes from the acid, and then you see how this electron, this pi electron cloud, it is pushed towards this oxygen atom of this OH, then giving rise to the formation of this carbonium. We see this is C plus, and which is then attacked by by these ammonia, by any ammonia derivative. We see because nitrogen has got a lone pair of this electron, so this is being a weaker this nucleophile, so it is for this reason that this reaction is carried out in a weakly acidic medium. Now you can see this when this lone pair of electron, it attacks this carbonium, and this is ammonium derivative. Now this is a protonated carbonyl, and you can see then when it attacks, then it loses a proton. Upon losing this proton, it gives rise to give this product, which then eliminates water molecule to give rise to the formation of the that to give the final this product. Now with a double bond between the carbon and the nitrogen or the ammonia derivative. Now G, as I have told you, it may be any group, various groups I have told you about a short while ago. I have told you about this. So now as I have told you, the reaction is carried out in a weakly this acidic medium. Now if we use a strong acidic medium, now the protonation, as I have told you, the protonation of this carbonyl makes this carbon more susceptible. Once this carbonyl gets protonated on this oxygen atom, it becomes more susceptible to nucleophilic attack, and therefore we expect the reaction will be favored and although we expect the reaction will be favored by high acidic medium. However, and as far as the acidic medium or highly acidic medium is concerned, that is not possible, because in that case, if we use a strongly acidic medium, this then the ammonia derivative, it being basic in nature, it may form the respective salt. You can see, if the medium is if the medium is strongly basic, in that case we see this NH2 group, it gets protonated and it gives rise to the formation of this it forms the respective salt. So, and that in that case this will not then act as a nucleophile. So it is for this reason that this reaction, that is the nucleophilic addition reaction followed by this elimination of water molecule, it is carried out in a weakly acidic medium and not in a strongly acidic medium. And I have told you why, because in that case this nitrogen may also get protonated, and we see that then it will not behave as a nucleophile. So we have got some of these reactions, or we have here this is the reaction with the hydroxyl amine. Its formula is NH2OH. Now you can see here, I have shown this is an aldehyde, and once it is treated with this hydroxyl amine, it gives rise to the formation of oximes. Now both aldehydes and ketones on reaction with this hydroxyl amine, they give rise to the formation of oximes. You see here, this is an aldehyde. Upon treatment with this hydroxyl amine, it gives rise to the formation of oxime. Now this is here acetaldehyde. When it is treated with hydroxyl amine, it gives rise to the formation of ethanol. This is ethanol oxime with the elimination of water molecule. Now similarly, if formaldehyde this is treated with, then it will form methanol oxime. Now then we have got another reaction, that is reaction with hydrazine. This is NH2NH2. Now when these carbonyl compounds, they are treated with this hydrazine, they give rise to the formation of hydrozones are formed. In that case, this is acetaldehyde. When it is treated with this hydrazine, it gives rise to ethanol hydrozone. And again we see there is elimination of water molecule with the double bond between the carbonyl carbon and the nitrogen of this hydrazine. So hydrozones are formed. Similarly, formaldehyde, it can form the methanol hydrazone. Then we have got the reaction with phenylhydrazine, and its formula is C6H5NH2. Now in that case, in this reaction, we see the phenylhydrozones are formed. In this case, this is ethanol acetaldehyde. When it is made to react with this is phenylhydrazine, again in a weakly, since these reactions are carried, I have told you that they are carried out in a weakly acidic medium. And I have told you why, the reason I have told you why it is why the reactions are carried out in a weakly acidic medium. So when this ethanol or acetaldehyde is treated with this phenylhydrazine, it gives rise to the ethanol phenylhydrazone. Similarly, if we treat formaldehyde with this phenylhydrazine, the product formed will be methanol phenylhydrazone. Then we have got another reaction, that is a reaction with semicarbazide, and its formula is it is NH2CONH NH2. Now you can see here, this is an aldehyde. I have shown here, this is acetaldehyde. When it is treated with the semicarbazide, this is NH2 NH2 NH2, then it gives rise to the formation of these semicarbazones are formed. You can see here, acetaldehyde reacting with the semicarbazide, it gives ethanol semicarbazone. Similarly, when formaldehyde is treated with this semicarbazide, it will form methanol semicarbazone. Or if we treat this benzaldehyde with the semicarbazide, it will form this benzaldehyde semicarbazone. Then we have got another reaction of this this type, that is the reaction with 2,4 dinitrophenyl hydrazine. Now with this 2,4 dinitrophenyl hydrazine, again we see the product of formed is, you can see, again it is again hydrazone. Now you can see this is acetaldehyde. When it is made to react with this 2,4 dinitrophenyl, this is phenyl hydrazine. The only difference is that we have got two nitro groups which are located at position number 2 and 4. You can see here. Otherwise this reaction is similar to that of this phenyl hydrazine which I have shown above. Now in this case we have got two nitro groups at this is ortho and para positions, that is at two position, and position number 2 and position number 4. So that is why we call it as 2,4 dinitrophenyl hydrazine. So when it is treated with this acetaldehyde, it will give rise to the formation of ethanol 2,4 dinitrophenyl hydrazone. Similarly, formaldehyde, it will give rise to the formation of this methanol 2,4 dinitrophenyl hydrazone. Similarly, when benzaldehyde is made to react with this, it will give benzaldehyde, it will give rise to the formation of benzaldehyde 2,4 dinitrophenyl hydrazone. So these are the various reactions in which we see there is nucleophilic addition, then followed by the loss of water molecule, or followed by the this elimination of water molecule. So this is for today, and in our next lecture we will discuss the addition reactions and then reduction reactions. So thank you very much.